This review, we're going to be going over linear concepts. Anytime you see the word linear, you should be thinking line. And also when you see the word linear or line, I recommend you thinking of these next three equations or formulas here. So the first one, I'm just going to mention them and then look at all of them. The first one is the slope formula between 2 points. The next one is a form of an equation. It's the slope-intercept form of an equation. And then the other one is the point-slope form of an equation of a line. Okay, so these are the three things I recommend you think of when you think of the, or when you see the word linear. So looking at the slope formula, if you have 2 points, x1, y1, and x2, y2, whatever they are, whatever numbers are in those parentheses, then you can find the slope, which is m, between the points. And this tells us, the number we get tells us how steep the line is connecting those 2 points. If we get a positive number for the slope, it's an increasing line. If we get a negative number for the slope, it is a decreasing line. And if we get a slope of 0, it is a horizontal line. If we get an undefined slope, meaning we divide by 0, then that means it is a vertical line. So the slope formula, make sure you have it memorized, is m equals y2 minus y1 over x2 minus x1. Change in the y coordinates divided by change in the x coordinates. And you might see it look like this using the Greek symbol delta. That means change in. So change in y over change in x, or rise over run. Okay, so that's the first formula. Technically, all of these equations are actually the same. They're just rearranged a little bit and used a little bit differently. Okay, next one is slope-intercept form for the equation of a line. So this one's an equation of a line. It represents a line and we can graph it, but it is in a certain form and it's called slope-intercept form. It's very obvious what this equation tells us. It tells us the slope and it tells us the intercept. So the slope is m as always, and b is the y-intercept. So this is in the form, the slope-intercept form is y equals mx plus b. Or it could be, we know that it could be f of x equals mx plus b also. So something like f of x equals 2x minus 5. That is slope-intercept form. The y-intercept is negative 5, and the slope is 2. This is, if it's in this form, then usually graphing it's pretty simple. Next form of the equation is the point-slope form. This form also tells us exactly what it says. It tells us point and slope. It tells us the slope, and it tells us a point on the line. So this equation is y minus y1 equals m times x minus x1. So that would be something like y minus 3 equals negative 4 times x plus 1. Okay, so not as maybe intuitive as the last form of the equation that we just saw, but this would mean that the point on the line would be negative 1 comma 3, and the slope would be negative 4 from the one I just wrote down. So like I mentioned here as what I typed up, when we're creating an equation of a line, more often than not, this is the equation that we should start with and then fill in the slope and one of the points that it crosses through. Okay, so let's jump to an example. Let's create an equation of a line with slope 4 that passes through the point negative 3 comma 6. So we are given, well, we see that it's a line. We're given the slope. We are given a point that it passes through. So we need the point slope form for the equation of a line, which is y minus y1 equals m times x minus x1. And we go ahead and plug them in. We know that the slope is 4, and x1, y1 is negative 3, 6. So that's going to be y minus 6 equals 4 times x plus 3. So notice that I didn't write x minus negative 3. You can write that, but just if you know you're subtracting a negative, just skip to adding the positive right away. So that's technically all you have to do. It didn't say solve it for y, so you can just end right there. But know that you can solve this for y by distributing the 4 and then adding the 6 to the other side. Okay, maybe I'll do that real quick just to show that we can do that. So technically that is an acceptable answer, but if we distribute the 4, then we get 4x plus 12. Adding the 6 to the right gives us 12 plus 6, so 18. So this is point slope form, and this one would be slope-intercept form. Next one, create an equation of the line with slope 3, negative 3, and point, it's passing through the point 2, 1. So we know it's going to be point slope form again, because we're given the point that a point that it crosses through and given the slope. Let's go ahead and plug it in. That's y minus 1 equals negative 3 times x minus 2. Okay, so you can solve that one for y like I did in the previous one, or leave it just like that since it did not specify. I'm just going to leave it just like that. Okay, so one more thing here, and this is actually the most important thing in regards to calculus. So we have a quadratic, the basic quadratic function here, which is graphed right here. In blue, that's y equals, I'm going to label it. I'm sure we all know what it is, I hope, but I'm going to label it. That's y equals x squared, or f of x equals x squared, whatever you want. And what we want is we want the equation of the line, which is this red one. So we want to know what is the equation of that line. We are given that the slope of the line is 2, and the curve intersects the line at x equals 1. So this point right here that they intersect, let me get a different color. This point right here in green, we know that that is at x equals 1. Okay, so creating an equation of a line, once again, you should be thinking, okay, well, that's probably going to be point slope, right? Y minus y1 equals m times x minus x1. So we know the slope, so that's going to be y minus something equals, the slope is 2 times x minus 1. We actually know the x value, right? It's at 1. So even though it's probably pretty obvious what we put there for the y value, because we can just look at it on the graph, the way we can be sure is just plug it in the function. So we can find f of 1, which is 1 squared, which is 1. So that means the xy point is 1, 1. Or the x1, y1 point is 1, 1. So that's going to be y minus 1 equals 2 times x minus 1. And let's go ahead and just solve this one for y just so we can see what it looks like. So add 1 on both sides, 2x minus 1. So that is the equation of that red line, 2x minus 1. You can verify it by looking at the y-intercept of negative 1 and the slope of 2, meaning it goes up 2 and to the right 1 to get to the next point on the line. Okay, so that's going to be something in calculus called the tangent line at that point. That would be the tangent line of f of x at the point x equals 1. It's touching the curve at that point, and it has the same slope or the same direction of the curve at that 1 point. Okay, so that is it for this review.